Selamat sejahtera, we are from DCC10032 Group 3. Today we will present about segregation on concrete. Before that, I want to introduce my group member. In here, we have Noel Eliza Marcelinus, that is me. Next, Ededri Edward, Ravenna Rantis, and Hazrul bin Stanley. Introduction. What is segregation in concrete? Segregation in concrete is a case of particle segregation in concrete application, in which a particle is solid tend to segregate by virtue of different in the size, density, shape, and other properties of particle of which they are composed.
Let's look at the definition of segregation. Segregation of concrete is the separation of cement paste and aggregates of concrete from each other during handling and placement. Segregation also occurs due to over-vibration or compaction of concrete, in which cement paste comes to the top and aggregates settle at the bottom. Segregation of concrete affects strength and durability in structures. In a good concrete, all concrete aggregates are evenly coated with sand and cement paste and forms a homogeneous mass. During handling, transporting, and placing, due to jerks and vibration, the paste of cement and sand get separated from the coarse aggregate. If concrete segregates during transit, it should be remixed properly before depositing. However, a concrete where initial setting time is over should not be used.
Factors that influence segregation in concrete mixture. Vibrating concrete for a long period of time or over the vibration of concrete, improper mixing in the concrete, which might include use of polygraded, the insufficient mixing time of concrete. Either the concrete is mixed for a lower duration or longer duration, they both cause segregation of concrete. Storing concrete mix for a long period of time or transporting concrete mix for longer distance, improper or insufficient compaction of concrete, improper mixing in concrete such as use of polygrade aggregates, excessive use of water in the mix.
Next is effect on concrete. First, segregated concrete is very weak in strength. Number 2, due to segregation after placing, the concrete is lower part of a hole of any significant depth can be stronger than that in the upper part. Number 3, segregated concrete does not give a homogeneous mass throughout the structure. Number 4, rock pocket, sand, strike, and porous layer in hardened concrete are the result of segregation. Number 5, due to segregation, excess mortar come to the top of the surface which cause plastic shrinkage crack. And number 6, a segregated concrete is difficult to compact properly. And this is an example picture of effect on concrete. Segregation occurs in concrete and causes the strength of a building to be low.
How to prevent segregation of concrete? At the time of construction, especially while using trenches measure, care should be taken that the concrete is not part of the high graded that 1.5 meter. Next, aggregate should be properly graded as it will prevent the segregation. To improve the viscosity of concrete, which prevent the segregation, an entertaining agent can be used. In case of mass concreting, where mechanical vibrators are used, care should be taken that they are not used a long period.
According to the concrete isolation test conducted by Srinivas Mathu from Department of Civil Engineering and Mechanics, Gautam University of Science and Technology, Hyderabad, India. Segregation is difficult to measure quantitatively. When concrete handled on site, it is immediately detectable. The table test flow, which is used to determine the workability of concrete, can also be used to determine segregation. Isolation is assisted by the shake used during the test. If the mixture is not cohesive, the large aggregate particles will spread and go to the edge of the table. In testing, another type of isolation can be thought of. The first aggregate was left as the cement paste ran from the center of the table. A concrete cylinder or cube is vibrated for about 10 minutes and then stripped to be checked for isolation caused by excessive vibration. Isolation can be found by looking at the distribution of coarse particles.
As a conclusion, segregation of concrete is difficult to measure quantitatively, although this can only be noted at the time of concreting operation. A sample of the existence of concrete in a slump test or sample of diffusion within a stream test provides a reasonable idea of separation.